Hi viewers, welcome to LMS Solution. Today we are going to see about ANN-MPPT for solar PV battery powered BLDC motor. Here we are going to design the system for 24 volt. That means the BLDC motor rating is 24 volt, 40 watts. This rating is taken from the following website. Here you can come. That means we can see this website. This is a rating of this motor. Here you can see that the rated voltage of the BLDC motor is 24 volt. The rated speed is 3000 rpm. The rated torque is 0.125 Newton meter. The rated power is around 39 watts and the rated current is around 2.5 amps. The peak current is 7.5 amps. The peak torque is 0.375 and the inertia of the motor is 0.33 and the torque constant is 0.05 Newton meter per amps, and then voltage constant which is equal to 5.235 volt divided by kilo rpm, and the line to line resistance is 1.35 ohms and the line to line inductance is 0.9. It's the same data we are going to use for design. That go to advanced mode and then you go to compute from standard manufacturer specifically. Just you click this data and then you can feed the data here. That means this is the data, so we need to feed here. That means here you need to choose the trapezoidal back EMF, and then the line to line resistance is 1.35 ohms and then inductance is 0.9 millihenry, and torque constant here you can see that the torque constant is 0.05. Just you have to put 0.05 Newton meter per amps, and then you can see number of pole per. You need to say number of pole per. So here number of pole is 8, pole per is 4, and then you can see that the moment of inertia here the total inertia is 0.33 kg centimeter square. Here you got to change 0.33 and then you have to change to kg centimeter square. And then you can click compute block parameters. This is a block parameter we have computed. Already computed parameter. You can see the parameter detail here. The resistance range, stator phase resistance is 0.675 and stator phase inductance is 0.0045, and then you have to click apply. Here you can see the same parameter will be reflected here. That means flux linkage, voltage constant. Here voltage constant is 5.236. Here go to this website. Here you can see that the torque constant is 5.236. The data will be, that means we are using the manufacturing data for this BLDC motor, and then CO2 disengagement. This is for here the 24 volt 40 watts BLDC motor, small size motor. So here we are going to drive this motor by means of solar panel and battery. So I'm going to choose this solar panel more than the BLDC motor power. So I'm going to assume the power of this solar PV is equal to 100 watts. The voltage at maximum power point is 17 volt and the current maximum power point is 2.941 amps, and I'm going to conserve 2 parallel string. The single string power is, single panel power is 49 watts. We are using 2 panels, total power is around 100 watts, and then you get that means the voltage is 1700 2.84 at the standard condition. And I'm going to choose the battery. I'm going to choose the 12 volt battery with a 100 Ah rating. And then here we need to design this. That means we are going to use the boost converter here. And here you are using bidirectional converter. So these two converter going to be designed based upon the power rating. Here the power rating of solar PV is 100 watts. The voltage is 17 volt. The voltage requirement in here it will be 24 volt. And then here the voltage in the battery side is nominal voltage is 12 volt. The requirement in the output current will be 24 volt. So I'm going to consider same power rating for the battery also 100 watts. Based upon this detail, you need to design LNC. While we created the equation, that means this equation used to for designing that boost converter of the PV side. This is a value of LNC, and then this is the design of bidirectional converter in the battery side. This is the equation, and then this is the value of LNC. The same value will be used here, L and C, and then here we are using L and C for the converter from the calculation. This one for the solar deep boost converter, and this one for a battery bidirectional converter, LNC. Next you have to apply ANN-MPPT. Here this boost converter going to be controlled by means of ANN-MPPT. For that I'm going to measure two input. Irradiation temperature when we process where is ANN-MPPT. We will generate the reference voltage, So this reference voltage going to be compared with the actual PV voltage, and then it going to be processed via PI controller. This PI controller will be generated the duty cycle. The duty cycle is processed via PWM generator. So this PWM generator is going to generate the pulse for this boost converter. So this pulse is going to be given here. This pulse will be given to this IGBT. This neural network MPPT try to extract the maximum power from the maximum power from the PV in all kind of irradiation and temperature condition. And then here we need to control this bidirectional converter based upon voltage control method. That means here the output, that means this is DC bus, so we need to maintain voltage around 24 volt here. We need to control this. For that we have to measure that voltage across this inverter or this DC bus, and then it will be compared with the 24 volt. So next you have to use voltage controller like PA controller. The error between reference and the actual voltage, this process via PA controller, and then it will be generate the duty cycle. From the duty cycle then we process via PWM generator, it will generate the pulse for that the bidirectional converter. This one. So this one will be controlled this two IGBT in the bidirectional converter in order to maintain the voltage across this DC bus always equal to 24 volt. And then here the BLDC motor drive from solar PV as well as battery. And now PV having more than 40 watts, then it will be drive the this motor and also when we charge the battery. And the PV power goes less than 40, but during that time battery comes to supply power to that BLDC motor along with the this PV para. So this is a logic of that being power flow in the system based upon PV power availability and the battery going for charging mode or discharging mode, and also drive the BLDC motor. Next we go for designing of that neural network MPPT. So this is a code used for designing that neural network MPPT. So then you go to simulate this one. You can see my YouTube channel yearly videos. So I explained about neural network MPPT for solar PV systems. You will get some better idea when you watch that previous video. So try to find out that video in my YouTube channel. After that, after completing this execution, finally get neural network. This neural network only we are going to use in that MPPT model here. It will be generate the reference voltage based upon irradiation temperature. If you want more detail about this neural network MPPT, try to go to my YouTube channel or my website. Comes to this website, and then you can search that neural network MPPT in this blog. You will get the better idea about that. Now I'm going to simulate this model. Here you can see that I'm going to fix the irradiation for that solar PV. That means 1600, 400 and 600. So it's going to be changed every 1 second. And then here I'm going to fix the torque for that motor, which is equal to 0.125 Newton meter. And then we have to simulate this model. I'm going to show the result of PV battery and battery SOC, and then power measurement in the different section, and then speed of the machine, and then torque of the machine, and then stator current and the EMF of the BLDC motor. Now we can see that at 1000 watts per meter square, the voltage is maintained at 70 volt in the PV side, and then the PV current is maintained at 5.8 amps because we are using two panel in parallel. The single panel having rating of 2.9 amps, and we are getting maximum power around 100 watts. Now we can see that the current initial, that means battery current around -2 amps. Battery during that 1000 watts per meter square condition, that battery going for charging mode. So you can see that SOC of the battery is keep on charging from 50% to 50.006%. And then here you can see this the power of the PV converter, the output power of the PV converter, so it's around 60. And then here you can see the power of the battery converter is around nearly around is -35 watts. And then this is load power. Once again in the check that PV converter power is not the PV converter power, that is a low power. That means we need to measure power from here. We need to put another measurement, and then I'm going to use this one, and I'm going to change to input inverter current. Here I need to change to input inverter current. Now I am simulating this model. Now you can see that PV converter power. Here we are having the PV power generation is around 100 watts during that 100 watts per meter square. The batteries current having -2 amps, and then PV having 5.9 amps, and then the batteries keep on charging for 50%. This is the PV converter power is now is around 95 watts. and then battery converter power is around -35, and then the load power nothing but the power input to the inverter is around 60 watts, and then voltage across that the inverter is maintaining at around 24 volt. This is the speed of the BLDC motor, and then this is the EMF of the BLDC motor, and then stator current and the back EMF of the BLDC. Now you can see that after 1 second the irradiation change from 1000 to 600. Here you can see the power generation from the PV is will be 60 watts. Here the power is 40 watts is reduced from that PV panel because of irradiation reduction. Because of that, what happened, the battery current is changed from -2 amps to nearly 1 amps. The battery now is discharging more. That's why SO said the battery is discharged from 50.006 to some level, right? And then you can see that the change of battery converter power from minus to positive. That means minus means battery charging mode, positive means battery in a discharging mode. That means here that because of change in power in the PV, the battery change from charging mode to discharging mode. Based upon that power from the PV, the battery change the state from charging to charging and discharging charging mode, and also is continuously supplying the power to the load. That means continuously we are supplying the power to the BLDC motor. So this is a working of this model. Thanks for watching our videos. Kindly subscribe the channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.